Alright, so for this video I'm going to be doing tutorials on how to solve problems regarding curved mirrors. So the first problem states that Bobby placed a 4.25 centimeter tall light bulb a distance of 36.2 centimeters away from a concave mirror. Now because it's a concave mirror, it's going to be facing away from the object, which would be here. If the mirror has a focal length of 19.2 centimeters, then what is the image height and image distance? So two things we're trying to solve here are the image distance, which is the distance between the reflected image and the mirror, and the image height, which is the height of the reflection. So first thing we're going to do is we're going to label everything that we have given. So the height of the object, the light bulb, is 4.25 centimeters or 4.25 meters. We'll just do this so we can keep all the units constant. And the distance between the focus and the mirror is 19.2 centimeters or 0.192 meters. So this little mark right here will be F, or the focal point. And the distance between the object and the mirror is 36.2 centimeters or 0.362 meters. Okay, so the first thing we're going to have to do is we're going to have to use the mirror equation, which is 1 over F equals 1 over dO plus 1 over di. Alright, so 1 over the the distance between the focus and the mirror, which we're given, is 0.192 meters, equals 1 over dO, which is the distance between the object and the mirror. So that would be 0.362 meters, plus 1 over di, which is what we're trying to solve for. So this would be 1 over 0.192 would, when rounded out as a decimal, it will be 0.025 meters, and that would equal, well, okay, so this number right here would be the result after you subtract the 1 over 0.362 meters from 1 over 0.192 meters. So this is including the subtraction where you remove that from both sides. So this would be equal to 1 over di. So what you would do here is you would multiply both sides by di. So 0.025 meters times di equals 1. You divide both sides by di, so you get 1 over 0.025 meters. Di equals approximately 0.4 meters. So that is that answers the first part of the question. Box our answer. Alright, so now we have enough information to use the we're going to be able to use the magnification equation, which is m equals hi over ho, which is the height of the image divided by the height of the object, which is also equal to negative di over do. Okay, so m equals, we wouldn't really need m because that's not really what we're solving for. We aren't trying to find the magnification necessarily. We're trying to find hi, and we're given ho, and that would be 0.425 meters, and that would be equal to negative di, which we just found, so negative 0.4 meters divided by the distance between the object and the mirror, which would be 0.362 meters. So these two can be divided right off the bat because there's no variables. So that would give you, so you would divide both of these and you would multiply it by 0.425 meters to isolate the variable. So you get hi equals negative 4.8 centimeters, or if we're converting the mirrors, then negative 0.48 meters. Alright, so now our second problem is very similar to our first one. So it states that Mr. H splurged when he bought his Yugo and ordered the side mirror option. Mirror has a focal length of negative 88.4 centimeters. We're trying to find the image height given that the object is 4.59 meters tall and that the distance between the object and the mirror is 12.6 meters. So first things first, let's draw this out. Here is the mirror and here is the object. Now distance between the focus and the mirror is negative 0.884 meters. Like I did in the last problem, I just converted the centimeters to meters, make it simpler. The height of the object is 4.59 meters, and distance between the object and the mirror is 12.6 meters. And with all this given, we are trying to find the height of the image. Alright, so right off the bat, we can use the mirror equation, which is 1 over f equals 1 over do plus 1 over di. Now we have the distance between the focal point and the mirror given, which is negative 0.884 meters, equals 1 over the distance between the object and the mirror, which is 12.6 meters, plus what we're trying to solve, the distance between the image and the mirror. Alright, so right here we could isolate the variable by subtracting 1 over 12.6 meters from both sides. So 4 meters minus 1 over 12.6 meters equals 1 over di. And after you subtract them, you get something around 0.121 or rather 1.21 meters equals 1 over di. And after you well, I guess we could do that right here. So 1.21 meters, multiply both sides by di and divide both sides by negative 1.21 to isolate the variable. So 1 over negative 1.21 meters, and after dividing we should get about negative 0.83 meters. Now this isn't the answer, but it gives us everything we need to find the answer using the magnification equation. So hi divided by ho equals ti divided by do. Now we're trying to solve for hi. We are given the height of the object, which is 4.59 meters, equals this should be negative di. So because we're making a negative number negative, this would be 0.83 meters divided by 12.6 meters. Alright, so what you would do here, you would isolate the variable by multiplying both sides by 4.59 meters. 3 meters divided by 12.6 meters, and this should give you a final answer of 0.3 meters for the height of the object. Box in our answer, and there we go.